All right, good evening. Welcome back to Pre-Calculus. So we are talking about trigonometric equations. Excuse me. So let's have a look and see what we've got. We've got 2 cosine squared x minus 11 sine x minus 7 equals 0. Okay, so here we have 2 cosine squared x minus 11 sine x minus 7 equals 0. All right. Now, the first thing you're looking at here is like there's a sine squared, there's a sine and a cosine squared. In order to solve an equation like this, all of your trig functions kind of have to be the same thing. Okay, if they're multiplied together, you've got some options. But right now, they're connected by a plus or a minus. They all got to be the same kind of trig function. Okay, so what we're going to do is we're going to say, hey, I wonder if there is a way of converting a sine squared or cosine squared into a sine. Okay, because I'd rather like everything to be in terms of sines. Say, wait a minute, there's sine squared x plus cosine squared x is equal to 1. So that means that sine squared is equal to 1 minus cosine squared x. See, we just move that cosine squared to the other side. So we're going to replace, or actually, I'm going to do it the other way around. I'm going to say cosine squared is equal to 1 minus sine squared. Okay, inspection of this thing. So we're going to replace our cosine squared, okay, with 1 minus sine squared x. Minus 11 sine x minus 7 equals 0. Now we still can't combine these because we've got sine squareds and sines, so they're not gonna play together. But we are going to get a little bit closer. So we're going to go ahead and say this is 2 minus 2 sine squared x minus 11 sine x minus 7 equals 0. Now this is a positive 2 and a minus 7. I'm going to bet that makes 5. So we're going to have minus 2 sine squared x minus 11 sine x. We've got a positive 2, we've got a minus 7. So $2 and $7 in debt, which means we are really just $5 in debt. Equals 0. Okay, 2 times 5, that's 10. Can you think of two numbers that multiply out to 10 but add up to 11? Okay, I think 10 and 1 will do it. So what we're going to do is we're going to say 2. Actually, I'm gonna change my SIG ends here for just a second here, because I work better with positive coefficients than negative coefficients. We can work with both. I just want to do it this way to be to limit the number of errors I'm going to make. Okay, 2 sine squared x plus 11 sine x plus 5 is equal to 0. All I did was multiply everybody by both sides here by negative 1. That's all that happened. Okay. And again, 2 times 5 would be 10. 11 would be the sum of 10 and 1. Okay, so we're going to have 2 sine squared x plus sine x plus 10 sine x plus 5 equals 0. You see that sine x plus 10 sine x is going to be 11 sine x. Okay, and I grouped them here because I really wanted a 5 and something with the multiple of a 5 to kind of work out here. Okay, since this is just sine x is just 1 sine x. Okay, so this is going to stay sine x. Okay, we're going to have 2 sine x plus 1 factored out of sine x plus, there's a 10 and a 5 here. What do they have in common? 5. We have a 2 sine x plus 1 equals 0. Hey, would you look at that? 2 sine x plus 1, they are common to both of these factors. We're going to go ahead and sweep these out because that's how factoring by grouping works. So we have 2 sine x plus 1. And then we have a sine x plus 5 equals 0. So we can break this into two pieces. 2 sine x plus 1 equals 0. So we have 2 sine x equals negative 1. Sine x equals negative 1/2. Okay. On the other side, we've got sine x plus 5 equals 0. We're going to have sine x equals -5. Those are our two possible solutions. Now, when I'm looking at sine x equals -5, what does sine x look like? Sine looks like this, right? And here's a -1, here's a +5. Where the heck is -5? It's down here somewhere. Do these two graphs ever intersect? No, they do not. So in this case, we're going to have a no solution here. Okay, because these graphs never intersect. Does sine x run into -1/2? It sure does in two places. Okay, so you have to remember, like, where's the sign negative? All students say calculus, the sign is positive in the first quadrant and the second quadrant, so it means it's negative in the third and the fourth quadrant. So the sine of what angle? Sine of what angle is equal to 1/2, provided that angle is going to be in the third or the fourth quadrant. Okay, you have to remember and say, okay, how does that work again? Oh yeah, sine kind of rises like this, so it's going to be a small angle in here. So I'm going to say something like, how about the sine of 30 degrees is 1/2? So we want the sine of pi over 6. That's not really the angle. The reference angle, right, is pi over 6. That's going to equal 1/2. Now, how do I cast that into quadrant 2? How do I cast that into quadrant 4? Okay, so that's going to be pi over 6. So what we're going to say for 1/2, I want this to be in quadrant 3. So we're going to have, here's pi over 6, here's 6 pi over 6. Going to say that 7 pi over 6, it's going to be right here. Okay, is 1/2. And then we want quadrant 4, that's going to be 11 pi 6. And those are our answers for that. You can always check, okay? I would prefer that you could do this by hand. I could prefer you would do it by memory, but you know what? I am not looking over your shoulder when you take a quiz to make sure that you are using the calculator. Okay, if you gotta double check this thing for yourself. Okay, what we'll do, say mode. We'll leave it in degrees. Put it down here. Put it in degrees. Degrees are always a little bit easier to work with. Okay, put out of that. And we'll just double check this, and we'll say sine. Okay, what we want? We had 7 pi over 6, so that's going to be 180 plus 30. It's going to be 210 degrees. Okay. Hey, what do you know? It's -1/2. And then if we go to 11 pi over 6, that's going to be 30 degrees, just shy of 360. Okay, so I want 30 sine of 330 degrees. Right, that's a little shy of 360. That's also -0.5. What are the odds? Okay, so that's how you go through and you make sure that you've got this. Okay, again, in an ideal world, you would have had these memorized, but in a less ideal world, you'll know how to manipulate the calculator enough to be able to make sure that you're right. Okay, so we're doing more of a guess and check here than to, nailing this stone cold. That's okay, but but we are going to be able to figure this out enough to be able to check it and know that we're on the right trail here. Okay, so even if you just have like, I know I'm close. Okay, we could also do this if you really wanted to double check this. Get rid of that. I want second function sine inverse of 0.5. I think that'll do it for us. Hit that 30 degrees. Now you have to have the intelligence state. Well, I want 30 degrees, but I want it in the third and fourth quadrant. Okay, so even though I've got my 30 degrees here, if it's going to be here, where's it going to be? It's going to be, like third quadrant, sorry, third quadrant. So here's 180. How do I get the 30 degrees here? Well, we're just going to add a little bit more. And here, that's -30, but I want it to be a positive angle, so I got to go all the way around here. So that's going to be 330 degrees. Okay, so I'm not going to give you a hard and fast rule for like how to get onto this, but once you know it's 30 degrees, you have to be able to just flip this around to which quadrant that you're looking for, right? So those are my answers here, is to say 7 pi over 6, 11 pi over 6. We'll go back here for a moment. So we'll say this is 7, say this is 7 pi over 6, just over 6. And then we want comma 11 pi over 6. All right. And that's our solution set for this guy here. Again, notice that the intervals are given to you in radians. Your answer should be in radians. We'll go ahead and check this. And it looks pretty good. Okay, so that's how you do one of those kinds of problems. Generally, if there's a lot of steps like this, I won't ask you for the general solution for n times around the circle. If you've only got 1 or 2 steps, then I will. But since this one already included like a factoring by grouping, kind of an issue, I think there's enough work that's already been done on this one. So I wouldn't worry too much about trying to get this every time. It's good practice. But yeah, generally, if there's a lot of steps, I don't want to make it worse. Okay, and at the end, it's like, what am I? What is a good correct answer? I think this is a good correct answer. Okay, so thank you for tuning in. I'll see you on the next problem, and try some of the homework on your own. Okay, good luck.